And 8.2 is, so 8.1 was multiplying and dividing polynomials, or rational expressions, that is. Now we're going to add and subtract, okay? The only thing here we have to remember is that you have to have a least common denominator, right? So let's look at, if I wanted to add 5, 6 plus 4 9s, what's the least common denominator for 6 and 9? What goes into 6?
3.
Well, no, but if I was going to make it the same denominator, what would I want to turn this into?
18.
18. That's the one I was looking for. Okay. So if I want to make this over 18 and over 18, what do I have to multiply 5, 6 by?
3.
So I'm going to multiply by 3.
Yes.
So that'll make this 15. And what are we going to multiply the 4 ninths, the top and bottom? Times 2. Okay. So what do we get? What's 15 and 8?
23.
23
Michael Jordan.
over 18. Okay, questions? Wait, that takes us way back to what?
Like the
Fourth, fifth
grade.
grade? Okay. All right, now. Here we're going to add these two, but we have to first factor out the denominator. So here we go.
Factor it out.
So let's factor out. So 3 over, what's the denominator? X squared minus 3x plus 2.
Yeah.
What's it going to become?
Oh, you mean x plus minus 3? No.
Has to multiply
I'm bad
together.
with those.
Okay, it's got to multiply
-3
together.
Or what? -1 3.
We've got to multiply together to give us a positive 2.
Yeah. Negative.
Oh.
Minus
Oh,
1.
multiplies to positive 2.
Yep. These two, if you multiply them, has to give us positive 2. When we add them together, we get negative 3. All right, what about the next one? What can I factor out of 2x squared and minus 2?
Yeah, check out the inference.
You can factor out. Okay, so 2 has to go in the beginning first of all.
Right, and then we get x squared minus 1.
Yeah.
So
Yeah, actually.
that's going to factor into.
X squared plus.
Okay. Excuse me. I like the light in here.
Are we gonna permanently move
It
this?
is amazing.
Yes, let's go. This room is such a nice room, pleasant room to have now.
Yeah, I feel like I'm doing math.
Look at all the
tree
green
house.
shrubs around.
Okay. What's my
They're
least
good.
common denominator here? We're not going to worry about multiplying it out. We'll do that in the next section. But what do they have in common?
The negative
X.
1.
They have an x minus. So basically what we're going to have a 2 times an x minus 1 times x minus 2 times x plus 1. So they only overlap with the x minus 1, and we need all the other factors. It's kind of like when we did 18. Remember, we were thinking about what goes into 8, right? 6 and 9 both go into 18. So, yes.
Just a quick question.
Mhm.
For the homework that was due today, it's extended to next class.
Yeah.
I have a question.
Chapter 8 is not on my jack.
I know.
I have a question. You want to have to there's 3x minus 1 and 1x minus 2. So why did you put only 3? Why did you say LCD equals 2? I don't get that. Why is the LCD that?
Because
Okay,
there's two x minus 1s in there.
So take into consideration the fractions that we did before. What's 6 equal to? 2 times 3.
Yeah.
What's 9 equal to? 3 times 3. So my least common denominator, I need to make sure. So I have a 2 and 2 3s that I have to make sure all of these. So I have to make sure 6 goes into this. So that's why I need the 2 and the 3. And if 9 is going to go into it, I need another 3. So I need to make sure you basically multiply together the factors. No?
Yeah.
Do you see it? Okay. let's find the least common multiple of each set of polynomials. So we'll start with the 15, the 16, and the 20. So let's see. All right. 15 is 3 times 5, right? 16 is 2 times 2 times 2 times 2.
Wait, why is it 2 times 2 times 2 times 2?
So this is what we call the prime factorization.
Why not just
Right?
18 times 2?
So if I'm looking at this,
It's the smallest number.
my least common denominator,
Why
That'd
not
be
or sorry,
factor out.
Can you just do 8 times 2?
Isn't it the greatest common factor?
that's something different. Greatest common factor is
Oh.
what goes into them.
Least common multiple is
Least common multiple is usually a
least
big number. It's the smallest number that they all go into, but it's going to be a big
Oh,
number.
so this one would have to be under.
So- I need a 3.
3, 2,
I need a 5.
3, 5, 2.
And how many 2's do I need?
2.
No, because if I only have 2 2's, 16 isn't going to go into that. Okay?
But then why do you?
So I have to make sure each of these factors is represented.
Only
So
one.
I have
But
3.
doesn't that make a number when you multiply all of those?
Yeah, we
So
are
is
going
the
to.
least common multiple a number is a single number?
Yeah. Okay, now let's do the variables.
Wait, how come you only have 4 2's?
Yeah, but these overlap.
Okay, yeah.
So you just need to make sure each of these go into
represent
this.
their own ones.
Yes. Okay, A I
Yeah,
have
so
A
you're saying
squared.
the first 2's.
Yeah. I have an A squared and an A cubed. I'm going to pick the bigger one. So I'm going to have A cubed. Because A squared goes into this. When it gets to the variables, it's actually easier. You just take the largest exponent. So the next one is going to be B,
B to the 5.
which is the largest one, the 5th, and C to the 6th. Okay, let's multiply out that big number.
Did we forget 5 at the end?
No, because this, do I have 2 2's and 1 5 already represented in the least common
You just-
multiple?
With those numbers, you have to be able to multiply using those numbers, all the ones above. Regardless.
It only has to be.
So 15, you use the 3 and the 5. 16, you use the 4 2's. 20, you use the 5 and the 2 2's. You know what I mean?
But where is the 5 at the for the 20?
It's in the beginning. You can use that 5 again.
Okay, when we multiply this out,
240.
240.
Don't look away.
Okay,
That's it.
that's it. Okay, when we have the polynomials, it's actually easier, okay? Take a look at this one. Let's factor this. What can I take out of each of these first? I can take out an x. And then I have x squared minus x minus 2. So that's going to be,
X.
So this is gonna
minus
be-
1 times minus 1.
no.
Minus 1. X.
Listen, guys, if it has a 2,
X plus 1. No.
the only way I can get a 2 here is by one of these being a 1.
2 and negative 1. 2 and negative 1. 2 and negative 2? No.
1 and negative 2.
Negative 2 and. Guys, 1 and negative 2.
Negative 1 and
Negative 1 and 2.
No, because when I combine these, I need to get a negative 1 here. Okay. Now, let's factor this part. So this is going to be, okay, what multiplies to
Don't
4?
say it, don't say it. Okay, I got it.
2 and 2.
2 and 2. And they both have to be
Negative.
negative. Okay, so my least common multiple. Okay, let's look at the first one. I have an x plus 1, x minus 2. We need all of these. Okay, now this one has 2 x minus 2's, but I only have 1 represented so far. So I need 1 more x minus 2. Okay, so you just have to make sure your least common multiple,
easy.
that they're all represented in the LCM. Okay, and that's it.
That's pretty easy.
Now, the reason we had to practice that is when we add them, we have to make them have a common denominator. Okay, so again,
You know LCD sound system?
what?
LCD sound system?
Do I?
This is LSD.
No, not.
LCD.
That's something complete. No. Okay. Yes.
You just cancel all the X's.
Well, you're gonna find out when we're not gonna cancel. We don't want to cancel anything. Okay. Let's see. What's the least common denominator here? Okay, so what's my least common denominator going to be? This is 2 times 3, and this is 2 times 7. So I have, what's the numbers we have for the least common denominator?
2, 2,
Oh, that's a 3, sorry.
2, 3, 7.
2, 3, and 7. And then it's going to be a to the, what power? 2, and b to the 2. Okay, so
on the bottom. What is LCD?
so this is all going to be on the bottom. So this is going to be 6 times 7. That's going to be 42.
The LCN.
Wait a minute. Wait, why are you doing 6 times 7?
Oh,
Why are you doing it twice?
Oh, right.
Okay, I'm changing. Okay, do you understand? I want to find a common. This is my least common denominator. So that's what I have here and here. Now, what do I need to multiply?
Should there also be b squared in the first one?
Oh, yes, thank you.
Let's go. Wait, actually.
All right. What do
Wait,
I
why'd
need?
you do it twice though?
Well, because you have
That's
to
my
switch
common
the
denominator. Remember when we did the fractions and I put them both over 18?
Sure.
Sure.
Sure. Okay, so if this is 42, a squared, b squared, what do I have to multiply the bottom by to get there?
7 b a squared.
7a squared b.
A squared.
So whatever I multiply to the bottom, right, to make that 42a squared, b squared, I have to multiply it to the top, which is going to be what? 35 a to the 4th b. Okay. All right, over here, I need to multiply the top and the bottom by
7
The top and the bottom go.
14 times 3 will give us 42, and then that's
no,
it.
That's it.
That's it. Just
Question. When you multiply exponents like that, you add, right?
so that's just going to give me 27 on the top.
So now we add.
Okay, now we add them together, but there's nothing I could do with the 35 a to the 4th b and the plus 27. We're just going to leave that,
That's our answer.
and that's our answer.
Can I try that?
Yeah, so let's factor the denominators first.
All right. So wait, I'm still writing. All right. So first, okay.
Why would you want to factor them?
Because I want to be able to combine these. We need to find the least common denominator. What happens when I take a 3 out?
You just,
x minus 5.
And if I take a 6 out?
Also x minus 5 actually.
Okay, what's my least common denominator?
distributing.
So x minus 5 is represented. So is it just 3?
Factoring is just undistributed.
Well, what's 6 equal to?
6.
2 times 3. So I need a 2.
Yeah. Okay. So 2 and 3 is already represented there. So
Yeah.
2 times 3 is 6. Yeah. So 6 x.
Okay, so in the denominator, I'm going to have 6 times x minus 5 minus 6 times x minus 5.
It's just times 2.
Ah, yes. So we look at what am I missing? I have to multiply the top and the bottom by just 2.
Is this being recorded? Good.
So what happens when I multiply the top? What about the next one?
And then just 3 is what it is.
Okay, I don't have to do anything with that, right? Okay, so now I get to put it all over one denominator. So I have 2x plus 20 minus, now if it's a subtraction, don't forget we have to distribute to both parts. So it's going to be minus 3x minus 15. What's that give us then? Combine like terms. Negative x plus 5.
Yes. Yeah, negative.
Bless you.
You don't do 6x minus 30.
No, in fact, I could go one step further. What do we notice about these two? They cancel out and you're left with
1 over 6. Negative 1 over
negative 1 over 6. Because it essentially what you have in the numerator is 5 minus x, and in the denominator x minus 5. So remember, those cancel to give us negative 1. All right. Let's factor here. What can this factor into?
Let's see.
2 and 3? Which one's positive? Which one?
You have to factor. Yeah, you do.
Okay, which one's positive? One has to be positive, one has to be negative.
Positive.
Positive 2.
Positive 2. Yeah.
Okay, and then this one here, I could factor out of 5, and I'm left with?
X plus 2.
Good. Okay, so my least common denominator is going to be what?
X plus 3. No, 5.
5.
Plus 2.
Does Mr. H randomly draw? If he asks you to recommend it,
Guys.
We don't know if he got 5.
He probably is a bus driver.
All right, so do we agree with this for our common denominator? All right. What do we have to multiply the numerator and denominator by in the first one? What are we missing?
Okay.
So look at the first one. We have the x plus 2, x minus 3. What are we missing?
5.
5. So I'm going to multiply.
The top by 5.
I'm kind of understanding this.
So we get 5x minus 5. Now what are we going to multiply here? What are we missing? So I have 5 and an x plus 2. I'm missing a x minus 3.
X minus 3.
So that's going to be 4x minus 12. Okay.
Alright, so now,
Okay, so remember we got to distribute. So 5x minus 4x. Can we do this all in one?
yeah, it's just
So just x.
x minus 17.
Careful.
Oh.
Negative 5
right.
minus
Minus
negative 12. So negative
Seven.
plus 7. And that's it.
That's hard.
Okay, I'm going to skip this next one so that we can just look at the last part. Question?
The last one.
Good? Okay, simplifying complex fractions. Okay, so if we can simplify the numerator and the denominator, and then we're going to...
What is this, like a matrix thing?
No. What's the least common denominator in the first one?
What? A, B,
AB? Okay, so I'm just looking at this. All right. What do I need to multiply the first one by?
Time B.
Times B
Times A.
and times A. So I get B and A here. Okay, what's my least common denominator here?
B. Wait, isn't it gonna be minus in the model?
Oh, thanks, yeah. So this is going to be 1 over B minus B minus B. All right, now we're going to combine. And then I'm going to show you a different, easier way, I think, on the next one. So we have b plus a over ab over 1 minus b over b. Shh, guys. Right? Okay. Okay, so remember, if you have a fraction divided by a fraction, you're going to keep the top one.
Yeah, you give the top one, and then you.
We're going to change this to times b over 1 minus b.
Yeah, that makes sense.
Okay.
That's the opposite.
So what do we notice? Does anything cancel?
Yes.
Yes. The b's. So I'm left with b plus a over a times 1 minus b.
And then cross cancel.
Pretty straightforward one.
No, we'll leave it.
No, I'm saying like you cross cancel up there, but don't you?
Because that's a multiplication.
Oh, you
Nothing
cross-
else is going to cancel here.
Well, wouldn't you cross?
It's going to be a worksheet.
Wait, but then you cancel out the b on that on the.
No, because it's attached to this plus sign.
I didn't know they could be attached by plus sign.
Okay, I'm going to show you an easier way to do this. And that is, what would your least common denominator of the entire problem be? Would be x times y. So if I just multiply the top and the bottom by xy,
1 minus 3, 2 minus 1 over y. I did that back.
okay. So if I just multiply everything times the least common denominator, it will simplify it in a much more efficient way. So what happens when I distribute here? What happens?
Y, it would be
2x.
2y.
It would just be 2y. Because if I, remember, this is over 1. So if I multiply this, what would happen? The x's would cancel and we'd just be left with 2y
It would be
over 1.
minus y.
And then minus distribute, minus xy.
Did not x times x though?
Yes, here, look. So it's x.
Oh, because that's not over x. That's fine. Yeah.
So if I distribute, this would be,
Oh, it's just x over x, which is nothing.
Literally.
you see it?
Yeah, x over x cancels.
Okay. Can we do the next one here? Okay, what happens when I distribute here? You're going to have, remember, this is over 1, so it's going to be xy over y. So x minus,
X minus
3y.
3y. So what we did in the last one could have been done all in one step. Just save us some space. Okay.